Okay. Now, before we define a formal definition, or before we discuss the formal definition of an algorithm, in a common way or common terms, algorithm is just like a blueprint. It's like a plan. Now, if we take an example of constructing a building or constructing a house or an apartment, now the very first thing is we have a plan. We have some measurements which contain some measurements. Based on the plan, pillars are created, walls are erected, and such things are happen. So algorithm is just a plan or a blueprint for a computer program. So we have an algorithm first, and using that algorithm, we try to develop a computer program. So in computer science terminology, algorithm is nothing but a set of instructions. And the most important thing, it's not only the set of instructions, but the set of instructions which executes in finite amount of time. Now this term finite is very important, because for a problem, we may have a solution, we may write a set of instructions, but not all set of instructions may lead to a solution in a specific time. So finite amount of time is very important here. That is, those instructions, what we write, which becomes a part of the algorithm, has to execute in some time. Now, let us take an example. Before we look further, let us discuss why we need algorithms, or why we need to learn algorithms. Now, let us take an example. We have a map. Now, in this map, we can, the problem I'm trying to solve is to reach from one destination, reach from a source to some destination. Now, moving from a source to a destination, there might be several ways or several paths. Now, those paths depends upon certain conditions. For example, one may be a shortest path, or another path may be a longer path but may not have traffic congestion. Now, there may be another route which has the flexibility of a train. So it is not only that we have to see that how to reach from source to destination, but we also have to see that how to reach from, what is the efficient way of reaching. Just a second. Anyway, let us continue. So, the problem is to reach from a source to destination. There may be several solutions, or several paths in this case. One path is it may be a shortest route in terms of distance. The second solution is we may have another path, and that path may be longer but without traffic congestion. Then the third solution is that we may have a path which from where we can utilize a train service. Now we have to choose among these three solutions, among these three paths, the path which is efficient. So now when we compare these things with our algorithms, to solve a problem, we may have several algorithms which performs the same task. But we have to choose, or we have to devise, or we have to use an algorithm which is very efficient among the existing solutions. So that is the main thing why we learn algorithms. That is, we have many solutions. From among those solutions, we have to find a better solution or an efficient solution. So if you see this, If I mean, this route may take 8 hours, 8 minutes. If you see, if I'm starting from this McDonald and reaching to this 890 Madison Avenue, from McDonald, I can take this path, which may be a shortest path, which takes 8 minutes. I may take another path, and it says 5 minutes here. And this path also says 5 minutes. So this may be the shortest path, which is 8 minutes in terms of distance, but there may be traffic congestion. The same way, I may take a longer path in terms of distance, but I may reach earlier because there may not be any congestion. So what we usually do is we try to choose a path which is efficient, or path which takes me from source to the destination in a lesser amount of time. That is what is efficiency in terms of moving from one place to another. So that is how when we have a problem, we may have several solutions. The same way we may have several algorithms, but we need to choose an efficient one or the best one. That is the reason we learn algorithms. So there should be a mechanism to compare the algorithms. That is what I said. We need to choose the best one. So how do we know which one is best? So there has to be a mechanism. That mechanism is nothing but we need to predict its performance. This performance we're going to learn later depends upon two criteria. One is the space and the other is the time. That is, time is nothing but how much time it takes to execute that algorithm, and space is nothing but amount of resources or amount of memory it utilizes. So that is why that is what algorithms are, and that is why we learn algorithms. Now let us look at the formal definition of an algorithm. An algorithm is a finite set of instructions that accomplishes a particular task, that is, that solves a particular problem. An algorithm depends upon the following criteria. What we see, what 5 criteria is what you see here. That is, the first criteria is that every algorithm will have some input. Without input, you cannot have an algorithm. You have to give an input for an algorithm. Then, after the set of instructions are executed, we get an output. That is, an algorithm, after executing the set of instructions in finite amount of time, has to give an output. Ultimately has to give an output. Then the next 3 criteria, that is definiteness, finiteness, and effectiveness, we will try to look at them using an example. So these 5 criteria are, and any algorithm has to follow these 5 criteria. Now let us take an example of ordering a pizza. Now, actually, the problem is I am feeling hungry. When I feel hungry, I have to eat something. Anybody feels hungry has to eat something. But here, it is not eating anything, a burger or a pizza, or a specific thing in this the problem is I want to eat pizza. There's specifics here. It's not general. It's not that the problem is not that I'm just hungry. I am hungry, but I'd like to eat pizza. Obviously, the task is nothing but I cannot just open a fridge and eat a pizza. I have to order a pizza. So that's my task. That's the problem. That the task I have to solve is the algorithm I have to write now is for ordering a pizza. These are the steps. Now what I generally do, I cannot go to any restaurant. I have to go find a pizza restaurant itself. I cannot go to a general store and say, give me a pizza or I want to eat pizza. That's not going to happen. then it's not that there's only one kind of a pizza available. There are several choices. Among that, we need to select which type of pizza I want to eat. Then after selecting, I have to place an order, make a payment, and then finally pizza is delivered. Now here, if you see these 5 steps are nothing but these can be considered as a set of instructions. And using these 5 steps in particular order, I would be able to accomplish ordering or making an order for a pizza. Now, we talked about that an algorithm, in a previous slide, we talked about that algorithm must satisfy the following criteria. That is input, output, definiteness, finiteness. These criteria are. So definition is fine. The algorithm is a finite set of instructions. These 5 criteria, that is input, output, that is every algorithm should have input, output. It should be a definiteness, finiteness, and effectiveness. And the very first thing is the input. In this statement, selecting the choice of a pizza is an input. Even making a payment may be an input. So every algorithm should have an input. Then when we talk about output, at the end, delivery of a pizza is an output. So that is considered as an output, the final result of this accomplishing this task. Now, definiteness. Now, definiteness means I cannot go to any restaurant. My statements or my instructions should be definite. That is, in this case, it is finding a pizza restaurant. I cannot go to a Lebanese restaurant and order a pizza. Or I cannot go to some general store and order a pizza. So statements have to be definite. It has to be specific. So that's what definiteness talks about. Then what about finiteness? Now finiteness is the order in which these things comes. These statements are defined. Are in sequence. For example, I cannot first select a pizza, then make a payment, or then try to find a pizza restaurant. So I have the statements should be in sequence, one after the other. It has to be executed in certain order. And the last thing is about effectiveness. Effectiveness talks about that every instruction should be specific. Along with it being specific, every statement should be so simple that it can be understood or it can give a solution to a larger problem. For example, I cannot just have, for ordering pizza, I cannot just find a restaurant and I cannot just say that pizza is delivered. I cannot just have these 2 statements in my algorithm, but because these 2 statements do not define the minute details which will be there, or the minute instructions which has to be executed in sequence for ordering a pizza. So if I just say find a pizza restaurant and pizza is delivered, that doesn't make sense because it is missing the details, that is the internal details of how things work. So effectiveness basically says that each instructions what we have should be understandable, should be should be a minute instruction, that is, which can be easily executed. So this is what is about a formal definition of an algorithm, which has these 5 criteria. So this was the basics of how we are, what an algorithm is and the formal definition of an algorithm. Now let us move further. Now let us talk about how algorithms are described. That is what we call as algorithm specifications. Now there are 2 ways of actually describing an algorithm. One is using flowchart, the other one is using pseudocode. Now flowcharts, as you all know, has some it's like a diagram where which tells you about the flow, that is how statements are executed, and based if we have a condition, there is a decision to be made, then if it is true, which statement should be executed. So it basically describes about the flow of the program. Now flowcharts are used, are very much suitable for simple algorithms. Flowcharts are not suitable for complex algorithms or to solve complex things. So the other way is to use pseudocode. Pseudocode is nothing but it's just like a description of a program, a description of an algorithms in terms of statements written like a programming language. It's like a programming language, not in a programming language. So algorithms basically contain statements. There is a body for the algorithm, and that body contains statements. And these statements are easily understood, and they are independent of a programming language. And pseudocode is generally using pseudocode, we try to solve complex algorithms. So throughout this subject, we will not be using flowcharts to describe algorithms. We will be using pseudocode because we are trying to solve not simple problems. We are trying to solve real-time complex problems. So that is why throughout the subject, we will only be concentrating on pseudocode, or how algorithms are written, or we will be seeing algorithms written in pseudocode. Now, the pseudocode, to create an algorithm in a pseudocode, what we have is these 9 different components. The first one is the algorithm definition. Now, as you might have heard about the how a function is defined. The same way an algorithm is defined. The algorithm will start with an algorithm as the keyword, then followed by the name of the algorithm, and within parentheses, the list of parameters what that algorithm takes. Now, they may, for a function, they may or may not be arguments or parameters, list of parameters. But algorithm will definitely have at least one parameter. Remember, that is what one of the criteria, that is input. We had as input. So an algorithm, though a function may or may not have parameters, they may or may not use parameters, but an algorithm will definitely have at least one parameter, followed by parentheses, and within parentheses, that is the body of the algorithm. Then the next thing is comments. Comments in algorithms, or when we write a pseudocode, just like double slash tells us that it's a comment. That statement has, is not executable or will not be executed. Then assignment statements are done using this colon equal to, using colon equal to. This is the assignment statements. So everywhere in the algorithms you may find assignment statement, not just equal to, that is j equal to 20 is, this is not the correct way, though in though all the programming languages we use this way to assign, but since pseudocode or algorithm is independent of a programming language, so we use colon equal to as the assignment operator, or I colon equal to 10 is known as the assignment statement. So we use it this way, not the J statement. Then blocks of code is written using parentheses. That is, for executing, we may have compound statements or we may group multiple statements together. That is known as a block. So in this case, if you see, starting from the parenthesis till the end of the parenthesis, this is a block. So I colon I assigned value 10, j assigned value 20. These are two statements, or these are multiple statements, which forms a block because they are within parentheses. This is just about, I mean, this is a, here we are trying to take an example of algorithm itself, but we may use blocks for conditional statements. We may use blocks for repetitive statements or iterative statements, that is for loop, while loop, do while loop, for if statement, if else statements. So blocks are compound statements are represented using parentheses, or what we call them as blocks. Then next is the operators. We have we use arithmetic operators, plus, minus, divide, percentage, and all for in algorithms. The same way we also have the relational operators as well as logical operators. Though for logical operators we use and or not, we don't use symbols there. I mean, that is, and we don't use ampersand at the symbol, or exclamation for not. I mean, or a pipe operator for or. We use words like and, or, and, not. Then the arrays are a collection of elements, are defined using square brackets. If we have a single dimension array, it's just a single square bracket with only one, the index there. When we have two-dimensional or multi-dimensional arrays, even then, for algorithms, we use single brackets, single square brackets, but depending upon the dimensions, that is the index I and index j, or depending upon the indexes of the dimensions, we separate them using commas. Then comes the conditional statements. We have if condition, then. This then is used. Remember here, we have then, this word, which you will frequently see in the algorithms. Though we don't use this word then in programming languages. For example, in C, we don't use then. In Java, we don't use then. Python, we don't use then. So basically here, since it's a pseudocode, the algorithm uses if, condition, then, followed by the statements. This statement can, this is only single statement here as an example, but you may have several statements. The same way we have if, condition, then statement, else statement 2. Here in algorithms, we don't talk about switch statement, or we don't talk about else if, though we have else if statement here, but we don't talk about the switch statement, because switch statements are, they are particular to a programming language. So we have if statement, if else statements, as if, even the else if statements. Then we have repetitive statements. Now here, the repetitive statements are nothing but loops, like for statement, while, and instead of do while, what we have in algorithms, or how we represent do while loop in algorithm, is using repeat until. So do while is specific to C, C++, and for Java. But in algorithms, if you have to represent a do while loop, we say that it is repeat until, or sometimes we also use do while directly. So it's basically what we say is algorithms are generally, I mean, uh, written in, is independent of any programming language. But you may find certain statements which look very much similar to some of the statements that are with respect to C, C++, and Java. So here we have a while, which is a keyword, and then the condition, depending upon, and followed by do. And if this condition is true, then statement 1 will be executed. The same way, the for loop, what we have is for variable we assign. So this is basically an expression. We don't use semicolons directly, but we say to some n, which is like the condition step of 1 or 2 or -1. So that way we have repetitive statements. Then the last thing is with respect to the input and output statements. Suppose if we have to take an input from the user, we use read as the function. Now, sometimes we need to take an input from the user, but usually the inputs are provided for the algorithm as a parameters. Then, for an output, we have write as the method. So this is similar to your scanf and printf statements of C, or cin and cout statement of your C++, or I mean this the out statement. For example, your in Java, if you say you have system.out.println. So these are the basic things, or what we say is about how algorithms are written. There are 9 components which we may use to devise an algorithm, and so that is what we call them as algorithm specifications. Now, let us look at before we end this class, let us take an example and let us look at how or what is the approach we apply to solve a problem. Now, let us look at a problem of finding the maximum from the n given numbers. So we have n numbers, like in this case we have 5 numbers here. Now we need to find the maximum number among this 5 numbers. So the problem is among n numbers. Now in this example I have 5, we may have n numbers. So what do we do? This is in computer science considered as a problem is general problem. Problem is general, that is I have a collection of numbers, a collection of elements. I want to find the maximum, who is highest among these numbers. So I have an array A, and if I have to solve this using computers, what I do is, or using program, or have to devise an algorithm, this collection of numbers is considered as an array. And this array has 5 elements that is represented by its index from 1 till 5. Though in programming language you start the index, or we say that the first element starts with the index as 0. But in algorithms, or whatever algorithms you may find throughout the subject, always the first element starts from index 1, goes till nth index. So remember that is what is the difference. So here, starting from first element, which is at index 1, till the last element, which is at index 5. So all these numbers are represented as an array. Then the next thing is, so here I have n as 5. Now the next thing is, in general, what do I do to find the maximum element or maximum number? I start with the first number, that is 84. I store that number, and then so let us say that I have a statement result equal assignment A of 1. That is, I'm selecting the first element, storing it in the result. So right now, that is my maximum element. But there are several other elements also which we need to traverse and find whether some element may be greater than this or not. So we move to the next element. 47 is not greater than 84. So to move from or to traverse all the other elements, what we do is we have a for loop where we start I, that is start from second. We take an index, start from the second element, move on till the last element n, in this case n is 5, and then we compare whether the element 47 is greater than the result. Result is the first element we have stored. If it is greater, then what we do, we change the result, but right now it's not greater, so we move to the next element. So this for loop for I 2 to n, and this condition traverses till the end. So 21, even 21 is not greater than, so this is false. So for loop is executed again. We move to the next element. We find 96. Now is 96 greater than 84? Yes, that is the 84 is the element which is present in the result. Yes, it is greater. So we change or we assign the current element, that is A of I, which is 96, to the result. So instead of result being 84, now result will be 96. Then we move further to the next element, that is 15. 15 is not greater than the result 96. So this statement will not get executed. And since we have reached the end, this for loop terminates, and we have the result. We have the maximum number stored in the variable as a result, which is obviously 96 in this case. So this is how we perform, or try to take a general problem of finding the maximum from a number and devise steps. These steps are nothing but instruction. That is, the first thing is result. It's an instruction. So this is what we are trying to devise an algorithm, and finally give the result. So the final output is the result. So all these statements, if you see, is nothing but we can say that this is an algorithm with the name as max, which takes array A as an input. Array A is an input. So when we say A, it is the collection of all these 5 elements, or n number of elements what we may have. And the next argument is nothing but, even this is an input, which is n, which is the number of elements, or the number of items in that array. And all the statements within the parenthesis nothing but forms a part or the body of this algorithm. So this is how we can take a problem and devise certain steps or instructions, and we can create an algorithm to solve this. Now this is one of the way of writing an algorithm. Now we may have several other solutions. That is, in this case, I'm starting from the first element, I'm moving till the end. Sometimes I may, there might be another solution, start from the last element, move till the first element. Or they may, other ways also, start from the middle element, then search this side or search that side. So it depends. That is, it depends upon the problem. So for every problem, we may have several solutions. That's the same way we may have several algorithms. Now let's move further. Actually, I have another problem, sorting and collection of elements. Now, solution is simple. We have an unsorted array or unsorted elements collection. We have to take the smallest element. The simplest solution I'm talking about. So this may not be an efficient one, but a simplest solution. Take the smallest element and place it in its place. Then among the remaining elements, again select the smallest element, place it in its place. So that is a very simple solution for sorting. Now, this is one of the solution for sorting. we may have several other solutions that we will look at when we move on to the subject. One of the technique that is divide and conquer, where we learn about merge sort and quick sort. I mean, that is those two are also sorting algorithms. So this is one of the solutions. So that way, the same way, we have several other solutions to solve a problem. Here, the problem is sorting a collection of elements. So we have a simple selection sort is one of the method. That is the simplest solution. We have insertion sort, we have merge sort, we have quick sort. So there are several sorting techniques. But what we need is we have to find which sorting technique is suitable in which circumstances, or which sorting technique is suitable or efficient in what circumstances. So anyway, so let us look at the algorithm. This is known, the very first step is for us to examine starting from the first element till the last element. That is n in this case is 5 because we have 5 elements. So we start from the first element, move on to the last element, and sort the collection, that is sort the n numbers. Now, to move from starting from first element till the last element, we use a for loop for I 1 to n, that is from first index to the last index. Now remember, here in most of the high-level programming languages, what we say is the index of the array starts from 0. But this is not this is a pseudocode. It's not. It's for the algorithm. It's not concerned about any of the high-level programming language. So in pseudocode code or in algorithms, we assume that the array index starts from 1 till the n elements. So we have for I 1 to n and examine all the elements from ai to an. Then we have to pick up a smallest element that we will assume that it is in the jth index. That is, it's at a of j. Then we have to interchange the element that is in the first position, because I is 1 right now, from the element which is at the jth position. So these are the basic steps what we have. But still, this is not an algorithm. Now, for an algorithm, we need to have steps in pseudocode that is understood by a computer. So let us look at how do we can translate that. Obviously, this for loop is going to be as it is, and then that is for I equal to 1 to n. Then this part is first task that has to be accomplished, and then interchanging the elements is the next task. So first task is to move from the elements and choose the smallest elements among the elements which are unsorted. And the second task is to interchange. The second task is very much easy. It doesn't take any logic as such. Just have to exchange 2 elements or just have to swap 2 elements. Now, this part can be done using a temporary variable t and assigning the value of a of I. Then to that a of I assigning the value of a of j, and then a of j assigning the value of the temporary stored value, that is t. The second task, the first task, it's a little bit complicated. And here, the very first thing is we will use a variable as j, that is for the index. So j will be initialized to I. Then this part j will be initialized to I. Then we will have a for loop start with the index as k. So k will start from somewhere I plus 1 till, and then we compare and swap the indices. Now, if you look at the actual working of this. Okay, now let us talk about this part for loop or the task 1. Now, what actually happens is this task 1, the very first statement we have is I, because for I is initialized to 1, the I index. Then for this task, j is initialized to I. So I and j will be pointing to the same index. That is, initially I is pointing to 1, index 1. So j will also point to index 1. Then we have a for loop k which starts from the next index. So I is 1, I is 1, even j is 1. K is going to start from I plus 1, that is 1 plus 1, which is second index. And it's going to go until the end n. Now, each time what we do is we compare if a of k, that is this 47 value, is less than a of j, that is 84. So this is obviously it's less. So what happens is we have to move j to the place of k. So k is 2, so j will be assigned index 2. Then this for loop continues. Next time k will be to n. We have to go till n. So k will be index 3. So k will move to index 3. Again, this if statement is checked. That is, if 21 a of k is less than a of j, that is 47. Yeah, it's true. It is less than 47. So j will again move. Then once again we are in a for loop. So k will move to the next location. That is, k will move to 96, element 96. And then if a of k, that is 96, is less than a of j, which is 21. This check, it is false. So k will not be assigned to j. That is, j will not move to kth index. It will not move. Then again we have a for loop. So for loop continues till the end last element. So here k moves. Now k is pointing to index 5. Then k is pointing to index 5. That is, if we have the if statement a of k, which is 15, is compared with less than 21. So this is true. So j will move to k. That is, k is fifth index. So j is assigned the fifth index. So it moves to the fifth index. Now at this point, k, this for loop has completed. So that is, for loop for k has completed. We reach the end of the the array, and now j is pointing to fifth element. And now we have to swap. What are we swapping? We are swapping a of I, which is 84, because I is index 1, so it's element 84, is swapped with element 15, that is a of j. So these two elements are swapped. So we found this for loop, using this for loop, we found the smallest element among the unsorted elements. And that is getting replaced with the first element. So the whole algorithm, if you see these steps, the entire steps of these algorithms, that is two tasks. That is, one task is to examine all the elements and then choose the smallest element at some place a of j, where j is the index, and replace that, swap that element with the first element for the first iteration. So this becomes an algorithm, and this algorithm is very popularly known as a selection sort algorithm, because for loop, in the first stage, for loop, we start with I, that is the first I, the first round we say, we start from the first element, find the smallest element and place it, selects actually the smallest element, place it in its place. Then this for loop will again execute with when I equal to 2, that is, I will start from the second element, and again same procedure continues. J will be pointing to the second, k will start from the third element, this continues. So this is known as selection sort algorithm. So this way, we last class we have just seen a simple algorithm of finding the maximum element, and in this session we have seen how to perform a sorting, which is a simple sorting method we have seen, known as selection sort. Now, why are we seeing these examples? Because to have an idea about how the algorithms are, or how the algorithms are written. It's not written in high-level language. They are written in pseudocode, and the statements are almost same as the high-level language, but this is how we are going to have the algorithm. And throughout this subject, when we move further, we will be analyzing these algorithms. and knowing its complexity, or knowing actually trying to find its performance.